All right, welcome to this lecture on the different types of CAD. So this is going to be kind of a history lesson about where CAD started from, where it went, how it's changed over the years. So let's go ahead and get started. So you can see here, big history, lots of changes. So first thing is 2D CAD. Okay, we started out in 2D, then there was 3D NURBS, that was developed, then that led to 3D surfaces, ACIS solids, and then we got into these parametrics. So parametric history based, 2D parametrics, and 3D parametric direct. So we're going to kind of go through those so you can learn about the different types of CAD and how they're used and what kind of makes them different. So let's go. So 2D CAD is basically just doing hand drafting on the computer. So you're telling the computer, draw a line here, trim this, and you tell it exactly how big to be as you're drawing it. You can always move things around and copy things. But when you draw the geometry and you move it, you're setting the size of it. And then you can add dimensions to measure what's drawn. Just kind of like it was by hand. But it's a lot more precise. By hand, you're using whatever the thickness of the pencil, and you're trying to figure out what the measurement is. In 2D CAD, you're keeping exact precision down to many decimal places. Like AutoCAD keeps, I think, 9 or 10 decimal places worth of precision. So it knows exactly what that number is. So this 2D CAD started in 1960 with Sketchpad. And then in 77, MicroCAD came out, which was renamed AutoCAD in 82. So the next thing was 3D NURBS, or I guess this is just NURBS. Let me take that out there. It was used for 3D also, but it was a way of kind of calculating a complex curve. We still use the idea behind this when we draw splines. Even in 2D, but it was used for 3D surfaces also. So we could have a complex curve, kind of like, like a grip of a camera or something like that. They could draw that. It was first released in 69 under NURBS, or how do you really say, with the O with the thing, the umlaut, I think, or whatever it's called. No, that's the U. I don't know. Whatever that O with the two dots is, that's the name of it. Kind of some of the programs still use the NURBS kind of stuff for surfaces. You can also do it with some solids. Then we got into 3D surfaces, kind of using the NURBS. This was making complex surfaces and then using those surfaces to define the sides of an object and the multiple surfaces of an object. So this was started. The first major program that did surface modeling was CATIA in 77, used by Boeing for designing airplanes. We'll do a little surface modeling later on in this class. When I started, we had to do everything surface. We had to do wireframe where you just draw lines in 3D, and then we add surfaces to those. We did it in AutoCAD when I started. Well, I'm not going to make you guys do it because it's a pain. But we'll do some complex surface stuff in Fusion so you can see kind of how it works. There's sometimes it makes those complex things a lot easier. The next thing was 3D ACIS solids. And so these was a modeling kernel that was released in 89. So a kernel is kind of a piece that goes into a program to make it do something. And so they developed that kernel that could make these solid models that had mass, they had volume, and you could add and subtract from them. And we weren't just talking about the surface of it, we were talking about the entire model itself. The kernel was introduced into AutoCAD R13 in 94, and then AutoCAD's had that since then. But that allowed us to kind of make a jump forward in using solid modeling. So then kind of the next thing was 3D Parametric Direct or Synchronous modeling. This lets you to create a solid model and then directly edit it. So back in the ACIS solids, you draw a solid, and if you wanted to change it, you'd have to make another solid and add or subtract from that original one. You couldn't just grab it and move a face or anything to change the size. With Parametric Direct, now you can go in and just grab the face of an object and move it over a little bit. It made it a lot easier to interact with that solid model. So Solid Edge had what we call parametric history-based, and also did some direct in 96. CAD Key introduced direct modeling in 99. Revit is an architectural-based program. So far we've been talking about some general ones. Solid Edge was mainly for mechanical drawing, so drawing parts and pieces and things. So CAD Key was still kind of general. Revit was specifically architectural based. So it was a full 3D environment meant just for architecture. And so you want to draw two lines, you draw a wall. And then you'd put a window in that wall. And then you could click on the dimension and change the size of those elements. And then Space came out in 05. And this is kind of where direct modeling for mechanical really took off. So then there's history-based parametrics, and so you can kind of see the timelines are kind of, this one starts a little bit earlier here in 89. Oops, I should just probably switch these ones back. But in parametric history-based, we're not just drawing an item and then measuring it. We're drawing item geometry, and then we're defining relationships between those different pieces of geometry. So you can say, we want these two lines to be parallel. I want these two to be perpendicular. I want this circle to be tangent to this other line. I want these two lines to be equal lengths, things like that. And then once you draw the geometry, we can add a dimension to it, and the dimension will change the size of the geometry. So if we pick two lines and tell them to be parallel, then add a dimension between them and tell it to be a different number, it'll move the lines accordingly. Or if you click a line and just tell it a different length, it'll change that length, or the diameter of a circle, or things like that. So now we're not stuck having to draw everything the perfect size to start out with. Now we can go in, draw it, and if we want to make changes, we can just change the number and the item changes. And so that's the history-based part, because how it's built kind of sets the rules for how it's going to change when you change a dimension. In direct modeling, you change a dimension and it just changes that dimension, doesn't affect anything else. But history-based, if you define it, like you say, the midpoint of this is going to be aligned with the midpoint of this, and you change the width of it, it's still going to stay centered. So that's kind of its big benefit. A downside is that if you delete something that other things were based on, then your model breaks, which can be a real hassle. In direct modeling, you can delete anything at any time and it's not going to break the model. So kind of some pluses and minuses. Direct modeling is kind of better for the concept stage of things, with the exception of Revit, because it's kind of its own thing. But for mechanical drafting, mechanical CAD, or what we call MCAD, direct modeling is kind of the first stage. And once you get an idea of what you want, then you can jump over to history-based modeling to kind of fully define it and make small changes that are based on rules. So this started with programs called T-Flex and Pro Engineer in 89. Pro Engineer is now called Creo. So it's still around, still a huge program. It's owned by a company called PTC. Big companies use Pro Engineer and Creo. Then SolidWorks came out in 95. And Autodesk, which is the company that makes AutoCAD, just saw that kind of where things were going and jumped on the bandwagon. They didn't have their own fully 3D program like Pro Engineer or SolidWorks, but they did have this great program called AutoCAD that a lot of people were using, and most of the people using CAD were using AutoCAD at that time. And still AutoCAD rules supreme in the 2D CAD category. And you saw that they had added some ACIS modeling back in, what was it, 94. So 2 years before they'd started doing some 3D stuff in AutoCAD. And so they made what we call a vertical product. And so they did a lot of these. They had mechanical desktop, they had architectural desktop, which kind of came before Revit. They had a civil desktop, which were programs that ran inside of AutoCAD, but then had extra abilities in them. So mechanical desktop added some parametric history-based abilities into AutoCAD. The problem was you had to first know AutoCAD and all of its 2D commands, and then you had to learn how to do the history-based in addition to that. And because it's still trying to rely on the 2D interface for AutoCAD, it really had some clunky elements. And I started using this here in 96 in mechanical desktop version 1. They quickly realized that wasn't working. They needed a fully 3D environment. And so they came out with Inventor in 99. And then they officially dumped mechanical desktop in 08, I believe. So that's not an available option anymore. Same thing, they dumped architectural desktop and stayed only with Revit because they realized that the pure 3D environment is better than trying to mix the 2D and 3D. This class 4B used to do 2 or 3D in AutoCAD, but as you can see, we're not doing that anymore. I've kind of switched up, so now this class is on direct modeling. So that's why we turn the history off when we're in Fusion. And that's kind of something for you to look up is, when did Fusion come out? And there's a little trick to that. There's a program called Inventor Fusion that came out, which was trying to add some direct capabilities to Inventor that didn't go anywhere. It really kind of sucked. And then Fusion 360 came out, and that's what we're using in this class. And that's a much better program that can do both direct and history-based. And then AutoCAD kind of saw that, or Autodesk saw that Parametric was really a good thing. So they went back and added in some parametric abilities into the 2D versions of AutoCAD, or into the 2D parts of AutoCAD. So that you can draw geometry in AutoCAD in 2D and still add those geometric relationships and have it where the dimensions change the geometry. A real big part of this is what we call blocks. So think kind of symbols that we use a lot of times, but think that might need to change. So like if you're doing architecture, a door, you don't want to have to draw a door all different sizes. You can draw one size of a door and add some parametric dimensions to it. So when you insert it into a new drawing, you can tell it what size you want it to be, and certain parts of it are going to change. Like the width of it might change, but then the trim around it will stay the same size. And so that was added into AutoCAD 2010 and 09. And that's kind of your history. So there'll be a few discussions that you need to look at. So let me jump back over to here. So if we go into 4B, we'll go down to this lecture. I've got some extra resources for you to look at, to kind of see some of this information. The main ones that we'll be talking about in this class are 2D, kind of both just regular 2D and 2D parametric, 3D direct, and 3D history based. Those are kind of the three main ones that are still kind of mainstream today. And then we'll have these labs here, or these discussions. So the first one is CAD 3D Direct. Then there's another one for CAD history based, and for 2D as well as some other topics. So first thing I want you to do is, I got some general topics. So how does it work, or defining an attribute, the benefits of 3D Direct, major software packages, and are there any free versions? There are. I want you to try and find them. And then industries that use Direct CAD and how do they use it? And so for each of those questions, you can kind of find and reply to the correct thread. You don't have to reply to all 4 of them. And I want this to be a discussion. So post in 1 or 2, wait until someone else posts, ask questions, clarify, add additional information if they missed something, things like that. So, all right, hope that answers any questions. Go and look at the information. This is kind of a really rich subject. If you want to be doing this, knowing the history of how things developed is a real bonus. So, all right, talk to you later.